Hello everyone. Here in this post, we would like to discuss briefly how to study both translatory and rotatory motion together for a body. For example, we are having a smooth surface, or assume it's like a rough surface but slightly rough, and we are ignoring the frictional force. Let us imagine a body like a ring or a ball, and it is pushed. While this body is moving on this floor, it will have two types of movements. It will move on the floor and it will also rotate on the floor. So it is having two kinds of motion. This is called translatory motion and this is called rotational motion. Because of the translatory motion, it will have linear kinetic energy, that if the body is moving with a velocity v, its linear kinetic energy or a translational kinetic energy could be expressed as half m v square, assuming that m is the mass of the body. As the body is also having a rotational motion, it will have another kind of energy called rotational kinetic energy, and we can write an equation for rotational kinetic energy in the lines of translational kinetic energy itself. Half is same. The role played by the mass in translatory motion is played by moment of inertia in rotatory motion, and role played by the velocity in translatory motion is played by angular velocity in rotational motion. So rotational kinetic energy is half I omega square. That implies, if you are interested to calculate the total kinetic energy of the body, in this case total kinetic energy of the body is nothing but the sum of translational kinetic energy as well as rotational kinetic energy. So the value of the total energy is half mv square as well as half I omega square. Anyway, if you want to express the rotational kinetic energy also in terms of translational kinetic energy, we can write moment of inertia as mk square, where m is the mass of the body and k is the radius of gyration. That is the effective distance of the entire mass of the body from its axis of rotation, where the body is rotating about a given axis. And we can write as v equal to r omega, we know the relation, omega equal to v by r, then omega square will be nothing but equal to v square by r square. So we can write the total energy as, I can take half mv square common, 1 plus k square by r square, where k is the radius of gyration of the body and r is the radius of the body itself. So total kinetic energy of the body is, we can say half mv square is nothing but the translational kinetic energy, multiplied by 1 plus k square by r square. So what is the ratio of total energy of a body, total kinetic energy of a body to its translational kinetic energy? Simply depends on the value of k square by r square. That implies total kinetic energy by translational kinetic energy is 1 plus k square by r square. So it's this value we can identify depending on the type of the body. For example, for a ring rotating about an axis passing through the center perpendicular to the plane, whose mass is m and radius r, We know the formula, moment of inertia equal to mr square. This can be written in terms of radius of gyration as mk square. In this case, k square by r square equal to 1. Therefore, I can write total kinetic energy by translational kinetic energy is equal to 1 plus k square by r square is 1. That is nothing but equal to 2. That means kinetic energy, total kinetic energy is 2 times of translational kinetic energy. Our translational kinetic energy is half of the total kinetic energy. In the other way, in this case, the body is having equal amount of both translational and kinetic energy, rotational kinetic energies. Suppose if it is a solid sphere rotating about a diameter, we know the moment of inertia is 2 by 5 mr square. By equating it to mk square, I can get the value of k square by r square as 2 by 5. That implies total kinetic energy by translational kinetic energy is 1 plus k square by r square, that is 2 by 5, that is 7:5. That means out of the 7 total energy parts, 5 parts is translational kinetic energy and the remaining 2 parts are rotational kinetic energy. Like that, for any body, we can identify the fractional values of total energy to translational kinetic energy or translational energy to rotational kinetic energy and vice versa. Thank you.